Hi, so this is Woody KJ7YYI, and this project started as a need to replace the worn out relays in my Ameritron RCS-8V relay box. Now, what happened was I bought one of these online. It was very cheap. It was used, obviously, and the reason I got a used one is because I didn't know if I was going to like it. However, it turned out to be one of the coolest things I've ever bought for ham radio. Being able to sit at my desk with my radios and be able to switch antennas on the fly in the middle of a conversation. I can listen on my broadband terminated dipole, I can transmit on my DX commander vertical, and I can go back and forth no problem. So this was very, very cool, especially in the wintertime when I didn't have to go outside to switch antennas. So the problem was it was used. So eventually, one of the relays started sticking, and I would open the box up and clean it and file it and put it all back together again. And 2 days later, it starts sticking, and then another one started sticking. And I rearranged things because out of the 5 inputs, I use one of them just for testing antennas. So I really only have 4. So with one of them sticking, I was okay. But with 2 of them sticking, it started getting annoying, and then a third one started acting up occasionally, and I'm like, all right, forget it. This thing's wearing out. I need to replace the relays. Okay. There's no real way to do that, and I didn't want to buy a new one of these because they're expensive. $280. So if you go to RSV Enterprises, our MFJ, you'll see that these, here's the information on the RSV. This particular one is for 5. They have different ones for different connectors, but this one is for 5. And, it costs a couple of dollars. So I'm like, okay, I don't want to do that. And before I continue, I want to mention something important. When you get one of these, it does not come with the control line because they don't know how long you want, and a lot of people want very long control lines. In my case, I only needed about 10 feet. So a 10-foot control line costs about $11.98 for a 6 PVC stranded tin copper 6 cable wire. It's like a telephone wire, right? It's one of these things. So no biggie. Okay, all right. So we know what that stuff is, and if you want, different gauges or different sizes, you can get. I mean, you can go out to 30 feet for 20 gauge is $24. Big deal. Let's go heavier. 18 gauge, $35. It's like, okay, all right, whatever. 22 gauge. Let's do that. 30 feet. So it's inexpensive, right? So now, so I don't need that for this particular project because I'm replacing just the relay part of the box. But if you're going to do this from start, include that in your price. Okay, so I didn't want to replace everything, so I just want the relay. So I started digging around, and I was working on my truck, and I noticed the relays in there looked pretty heavy duty, and so I did some research online. I came up with these. Here's a box of 5 30-40 amp relays with harnesses. They're 12-volt relays with harnesses. They can handle 40 amps. I'm thinking to myself, okay, I run 5 to 600 watts RF. I don't think this is going to be an issue. And they were $16. I mean, it was like, really? Okay, that's too cool. I got to take a chance. So if I look at the relay, layout of the relay, here's an example, and it shows the device, which in my case is going to be the transceiver, goes here. One side is, I can't get it to stop doing that, so I'm just going to show you. But one side is the positive. It goes to a switch of some sort, and that goes to one side of the relay coil, and the other side is the common, the ground, the negative of the battery. So if you're running a shack that's using 13.8 volts everywhere, Bob's your uncle, right? You already got plus and minus in there. You probably got, all you got to do is hook this thing up to a power pole, right? Okay, so power pole with a switch, and let's see, you're going to have your transceiver here. Normally, the switch is in this position, which is down, because it's not energized. You could connect that to ground, right? So that means when an antenna is not selected, it's grounded. And that includes if you say right above this fuse here, you had an on-off switch, like is on the antenna switch box that I just showed you. So when the box is turned off, all your antennas are grounded. They're all grounded. That's like perfect, right? There are people out there who don't want them grounded. They want them open. I don't know why. I would never set my antennas up that way. I always want everything grounded when I'm not using it. But if you want that, fine. Just don't ground that connection. All right. And then the antenna, or the antenna itself, would come in on this line here, 30. Now they have it connected to the power because they're expecting this to come on and turn on like a headlight. Okay. But in our case, we wouldn't connect it to power. We would connect it to the antenna. So the antenna would normally be connected to ground. When the switch is on and this is energized, it goes to the transceiver. You don't need anything else. Okay. When it comes to the specs on the thing, let's see. I'll have to. It's the next sheet. But I also want to point out, this comes with these sockets, right? So they're pre-wired sockets. Now, if you had a bigger box than me, you could use the sockets, and that makes hooking this stuff up really simple. And these wires, the wires that come on here, they're 7 or 8 inches long. They were a good long length. What I did was I just cut off like 4 or 5 inches of wire from each of these, kept the sockets in case I ever need them for something in the future. But just used these wires. So I didn't even have to buy wire to wire this thing up. All right, so let's go back here. So that's what I found. And these are pretty cool. Here's the spec sheet for it. And the 3040 that they're talking about is normally closed as 30 amps, normally open as 40 amps. Okay, I mean that's probably gonna work, right? Now what I did before I built all of this was I took a bunch of measurements on what I already had working. SWR, impedance, how much power I was putting out on all the different antennas, all that stuff. And I wrote all that stuff down, and later on I compared it. Nothing changed. It was exactly the same. I've been running this for over a month now, and I have had 0 issues. And normally I run between 400 and 600 watts, usually around 450 to 500, but sometimes as high as 600. And oftentimes I'm only running 400. And other times I'm only running 50 watts or less. When I'm doing digital, a lot of times I'm just on 40 watts or 30 watts. So it works in all these conditions. Okay, so this looks like it's going to work. So the next thing I did was I took their schematic and I redrew it. And this is my version. Yellow connector 87 goes to the radio, and I just tie each of these relays. I take this line and I tie them all together because they're all going to the radio. So they all, at the SO239 that goes to the radio, which used to be this one here, but now it's going to be a different one. Those are all tied together. Likewise, the control ground for each of the relays, they're all tied together because each of these just needs its own wire. So the white wire here goes to whatever wire is switch 1, and whatever wire is switch 2, whatever, so whichever relay this is. And then the antenna, each of the 5 different antennas will come in their connector will be connected here, so it's connected to the chassis ground, which this big metal plate is. The one I'm replacing this with, it's the same, and they're all tied together too. So you've got transceiver, these are all tied together. The ground, these are all tied together. These are all individual, they come from a terminal strip, and these are all individual, they come from the SO239s that the antenna plugs into. So there's an SO239 goes to radio, 5 SO239s for the antennas, and that's it. It's very simple, right? So it's all laid out here. You can download this PDF on both the Tonto Amateur Radio Association website, n7tar.org, or go to kj7yyI.net and click on my projects link. So this is the inside of the Ameritron version. All right, they've got a printed circuit board. It's very nice. 5 tightly grouped relays. They're big, heavy-duty suckers. And this is the SO239 for the output, with a terminal strip for that control line that comes in here. And in our case, we're going to do something similar, just going to lay it out different. So all I need is 6 SO239 solderable connectors, a 6 terminal strip, metal black backing plate, and those 5 relays. And that's all you need, and some wire. So the 5 relays are $15.87. The terminal block, I got 2 of those for $8.99. That's these ones here. And the chassis mount connectors, SO239s, these kind here. You've all seen these and played with these, I'm sure. Nothing new or unexpected here. And they are $9.90 for 3, and I needed 6 of them. So that's all that was. And then at Home Depot, I found a 12-inch by 12-inch 28-gauge galvanized sheet metal for $10.47. It is literally just a 12-inch by 12-inch piece of galvanized sheet. And with some tin snips, you can cut that to whatever size you need. For the project box, bigger is better. I was trying to fit into an existing footprint, and so I had to really cramp things in. It was kind of annoying. I wish that I had a bigger project box to put them in, but I wanted to use the existing stuff that was there. So I had to cut it down and then finagle everything to get it to fit. But if I was to do it again, a 12-inch by 12-inch box, you can get like a plastic box that you can waterproof to put outside. Pretty inexpensive. Or you could get a little smaller if you lay things out. Maybe you're not going to do 6 connectors. Maybe you're only going to have 3 antennas on there, or even 2. And you can cut it down to whatever size you need. But this is a good start here. If you get bigger than that, the box is going to start to get really expensive. You're going to start paying $50, $60 for the box, and that's, okay. But anyways, so my total cost was $55.13 without the project box, and it would be an additional $67.11 if you needed that control wire. So that would be the whole thing. Instead of paying, what were we at? We were at $280. You're at $67.11, and that actually the $280 doesn't include the control line either. So instead of $280, you're at $55.13 plus the project box, whatever that's going to cost you. And that, if you're clever, make your own. Get a piece of wood or whatever. So here it is partially assembled. I've got the relays on here now. Like I said, I didn't use the sockets, and you can see why. I don't have room. The footprint was too small for what I was trying to do. So what I used is these, I already had these, and I'm sure you do too, these little crimp-on connectors that I also soldered. So I crimped them and I soldered them, and they just slide right on these connectors here. Put one of the 6 position terminals in here, and this is the output, and this is antenna 1, 2, 3, 4, and 5, and relay 1, 2, 3, 4, 5. What it's shown with here is the the signal coming in from the antenna, and the ground for the this is the ground that goes on the antenna, if I remember right, the red wire. So I think I used the same color wires. So pretty simple, and when I was done it looked like this. It's kind of messy, but I used rather than trying to take all of these wires, these are good sized wires. I forget what gauge they are, but they're heavy enough to handle this RF. You can see the control lines are much thinner. Instead of trying to tie them all together in a big blob for the two common, this is the common for the control line, and this is the common for the antenna, the output of the box that goes to the transceiver. What I used was these lever connectors. These are 5-position lever connectors. These things are awesome. I love these things. I have a bunch of these already. If you had to buy them, they're pretty inexpensive. You're talking $1 or $2 more to get a couple of those. And again, depending on how many of these things you're going to put in here, that you have to adjust your price accordingly. But that's it. So this is the same control line I was using before. In fact, the colors still match up. This is still antenna 1, 2, 3, like that. So, so there it is, and it fits in the footprint of the box. And there it is in place. Antenna 1, antenna 2. This is my spare. This is what I use for testing my antenna projects. I've had 2 recent amazing failures. They were one of them really should have worked, and it did not, but it was because of the position. It turns out I cannot put any antenna over my roof at all. Nothing. Absolutely nothing. I cannot run any antennas over my roof. I don't know why, but it causes all kinds of mayhem inside the house when I do that. Smoke alarms go off. It triggers alarm clocks. Lights turn on. It's crazy. And that was when I was 20 feet over my roof. I was still caught. So I was like, all right, never mind. I won't do that anymore. So anyways, that's a whole that's a whole other story. And as you can see, I love my ferrite cores. I use them liberally everywhere. Whether I need them or not, I put them on. Even if they don't make any difference, I still leave them on. This particular little choke here, this was necessary. This is for my end-fed half-wave that I feed at 20 feet in the air. It's at the end of a 100-foot cable, so I definitely needed this. And this actually improved both the noise and the SWR, believe it or not, which is interesting. The other ones, I don't think they're making a darn bit of difference, but they're certainly not going to hurt, so I put them in there. And this whole box is grounded, all right? So you can see here there's a cable, ground cable coming in. It's one of those what are they? What's the word I'm looking for? It's like a mesh. It's like a mesh cable, and it comes in and grounds out. This entire box is grounded through, I think it's 10 gauge wire. It's pretty heavy stuff. Copper wire, and it goes down just a few feet to 2 8-foot ground rods dug into the ground, because the ground is so bad here. And of course, this is my little box that I had before, and I'm still using the same one. It sits on top of my radio, and I switch antennas. If you were to make a switch box of your own, basically, I mean, you're only talking about something like this, and I included a half-amp fuse in here because I was like, well, they must have a half-amp fuse in here. It turns out there's not even a fuse in this box. It's just, it's pretty cheap stuff. But they do have a 5-position switch, and which, I'm indicating a 4-position switch here. 13.8 volts comes in. It goes through an on-off switch, which I did not include here, but it's a good idea, because then when the antenna box is switched off, completely off, all your antennas are grounded. So everything's grounded everywhere. And in fact, if I show you, if I go back up here, even my 2 VHF UHF antennas, I have a Yagi and I have a J-pole. The J pole it's already a DC ground. So just the fact that it's tied into this box means everything's grounded. So I normally have this switch in this position, and this particular switch, I forget who makes this, but it's also, the unused connector is also grounded. So the Yagi's grounded. In this situation, the J pole is always grounded. When the switch box is off, all these antennas grounded. Everything's grounded. Everything's grounded. So you get static from lightning in the area, and you got no problems. And so you got your 13.8 volt power supply or whatever you're using, batteries, whatever. Put a switch in here to turn it on off. Actually, I would put it on this side, obviously. And I do recommend, slapping like a half amp fuse or something. Say 250 milliamp fuse, something like that is probably all you need. And a box. You don't need the lights, and you do that if you want, but this is all you really need. And bingo, you got yourself a remote antenna switcher. So, like I said, this PDF is accompanying this video someplace on my website, kj7yyI.net, or go to n7tar.org and look under, this will be under news, I guess, or maybe resources, I don't know, someplace. Anyway, you'll do a search on the site, you'll find it. And that's it. For those that are at my live presentation, I will now take questions. Thanks.